Let me show you these pictures. When we see this kind of the image, we easily think this grayscale is very high. So this bone looks very white. So maybe this bone quality is very dense, right? But this is the same view. But when you see this kind of the image, oh, maybe this patient's bone quality is very poor. It is very subjective way, not objective ways. So using a human eye, we cannot interpret the qualities. So that's why, because we make some digital eyes. It's very simple logics. The CBCT grayscale image is totally different, depends upon the machines. So, but this is the digital data. So all of the digital data have their own digital values. So most important thing is standardization, right? So whenever we taking the CBCT, there is only one material existing in common materials. What's that? Air. So look at this. This area is the air. So if we change this air as the same digital values, we can change different CT image as a standardizations. So I change this air as a dark color, and based upon these logics, this ugly CT view change into the full color range like this. It's a very simple engineering. And these kinds of the spectrums, we can easily detect the bone hardness. So if you see the black color, this is the air. Air means density is very, very soft. And if you see the red colors, it is very soft. It's soft as a soft tissue. Here is the soft tissue area. And if you see the blue, this is the almost medium hardness. And if you see the yellow and greens, it's a very hard also. Very intuitive ways. So, did you know this patient bone quality? We don't know using a grayscale. But after standardization and then changing the color code, we can easily know this patient bone quality. How about this patient bone quality? So yellow color here, hard bone. So before surgery stage, we can get a patient bone quality. How about this? Here is the air, black color, and red color is the soft tissue, and here is the cortical bone. Cortical bone is a yellow color. It means hard bone. How about the trabecular bone? It's almost the same color as the cortical bone. It means this patient bone quality is very hard bone case. Especially, look at the boundary of the implant surface. Almost implant boundary is contact with the yellow color. It means we will place this implant in a very hard bones. Okay, this patient bone quality is very hard bone. How about your drilling strategy? When you're using the taper implant, especially in a hard bone, sometimes your implant is stuck in the middle of part. At that time, you cannot go forward and backward, right? How many people experience about this kinds of the situation, right? That's why, because we cannot know the bone quality exactly. So when we're using the taper implant and when we met the dense bone, we have to prepare almost the same as the outline of the implant picture. It's very important things. After that, if we obtain a high initial stability, we can do immediate loadings. So this color code system is very intuitive systems. So the real strategy is very simple. In hard bone, we prepare almost the same as outline of the implant. In medium bone hardness, it is the conventional way. It is the 0.7 under drilling. And in soft bone, there is a small drilling, and using a self-tapping implantability, we place the implant picture. It's a simple strategy. Let me show you two cases. How do you think about this patient bone quality? Soft, extremely soft, right? Because here is the palatal soft tissue, and here is the inside of the bone. It means this patient inside of the bone density is the same as the soft tissue. This bone can vary about the immediate loadings? No. So in this case, we have to follow the conventional loading protocols. But most important strategy is this. This patient bone quality is poor, so anyway, we have to obtain a nice initial stability, right? After that, waiting 2 or 3 months, and then we have to apply the loadings. So, in this case, what is the best strategy for the drilling? Small drilling and using a self-tapping abilities. So, in this case, using a virtual program, Outgate, I decided the diameter 4.0 and length was the 10. My drilling strategy is, my final drill is 2.8 diameter. And then put in a 4.5 diameter like this. Increasing the drill length first. After that, increasing the diameter, 2.8. And then pick up the 4.5 implant and put in an implant. Because this is the soft tissue, kind of the soft tissue. So I obtain a 35 Newton and IS value is 72. Even though 35 Newton and IS value is 72, it's good for the immediate loading size, but mechanically, this bone condition cannot bearing a loading. So in this case, we have to follow the conventional loading protocols. So, these two implants. Actually, I always say, this patient is my mother-in-law. So this is the kind of the gift. So all of this implant was placed using a guide. Using a guide, we can obtain these kinds of implant position. So at the starting time, 4 implant and all of the implant was immediate loading, 1-day implant. And she can eat this, and then I placed the 2 implant and I placed the 2 implant. Anterior 2 part is the immediate loadings for the aesthetic reasons. For posterior is follow the conventional loading, and then place the 2 implant. Also follow the conventional loadings. Yes. And all of the prosthesis is used by the CAD technologies. Yes, let's talk about this case. How do you think about this patient bone quality? Extremely hard bone. There is no cancerous bones, right? So, in this case, the drilling sequence is very, very important. So, in this case, I choose the average diameter 3.5 and length was 10. So, my drilling strategy is very simple. I prepared almost the same as outline of the implant. So actually this aneurysm is 3.5, real diameter is 3.9. It is some strange things, but many Korean products like this, not only magazine implant, but also Dentium Obstem, they always say, if they sell the 4.0, the real size is 4.3 or 4.4. It's a little bit different. So aneurysm implant, the real diameter is 3.9. So my final drill was the 3.8. But this picture shape is the taper shapes. So like an endodontic treatment, I make the drill step backs. Using a straight drill, if I make some step back sequence, I make the taper bone preparations. Can you understand me? Yeah. So my drilling sequence was this. 2.8 by 10 was the full depth, and then 3.3 by 8.5. It means I shortening the files and increasing the drill diameter. And final drill was a 3.8 by 7. Using this, I make this kind of the taper shape bone preparation, and then I pick up the 3.5 by 10 and put in an implant. Can I obtain the initial stabilities? Yes, because this bone density is very, very nice. So I placed in a right position and checking the top value, 60 meters. How about the ISQ? 74, 74. So it is good for the immediate loadings. So immediately connecting the ready-made provisional aspiration. After that, making the final restoration. This is the titanium customized abdomen and the zirconia prosthesis. So let's get into the clinical case. Do you remember the numbers? How about this patient bone quality? It's a medium hardness bone, right? So based upon the medium hardness bone, I make the drill sequence. At that time, I obtained a 50 Newton and ISQ value is 70. So medium bone hardness, insertion top value is very nice, ISQ value is nice. So it's good for the immediate loading or provisionalizations. It is very clear protocols. So implant design, taper, and surface SRA or modified SRA, and implant position. We can get implant position very easily using the guide. And how we can checking the initial stability? Two ways. One is the top value, insertion top value, and the other is the ISQ value. And if these two signs say good initial stability, we can connecting the prefabricated customized abdomen. This is a very logical way and scientific ways, and this is the basic concept of the one-day implant systems. So we have to edit the one factor bone quality. So we called this is the diagnostic triad. Bone quality, ITV, ISQ value is very important. So you can say that this kind of the situation, if we meet the hard bone, it's a natural things. We met the favorable insertion top value and we met the favorable ISQ value. We can meet when you meet the medium bone, also same situation, but in soft bone, sometimes we can see the very strange things. Unfavorable ITV, but when you're checking the ISQ value, it shows sometimes good signs. It means only based on ISQ value, we cannot decide the immediate loadings. It's very important things. Some author or some speakers say, if you obtain over 60 or 65 ISQ value, it is good sign for immediate loadings. I cannot agree about this. I'll show you one case. Now, This is the article base. It is very important data. This is the insertion torque value, and this is the ISQ value. How about the ISQ value over 65? Even though there is no cortical bones, only trabecular bones, we can obtain easily over 65 ISQ values. It means in a loose bone, in soft bone, we can obtain a high ISQ values. But if there is no cortical bones, we cannot obtain a nice insertion torque values. Which one is more reliable data? Actually, in my opinion, insertion torque value is more reliable. It means in hard bone, we can obtain a high insertion torque value. But in a loose bone, we cannot obtain a high insertion torque values. So insertion torque value is more related to the bone densities. Okay. How about this patient bone quality? From now, you can see the patient bone quality. It's almost the same as the soft tissue. So very poor bone, right? So drill strategy is very simple. Small bone preparation and put in an implant, right? So my drill sequence was this. Initial, secondary, 2.0 by 10, 2.0 by 7, 11.5, 2.8, 11.5, and shortening, 3.3 by 7, and then place in a 4.5. It's an N1 implant. Also, it has a deep strand. And put in an implant. And checking the toe, obtain a 50 newtons. Remember the 50. And when I'm checking the ISQ value, 75, 72. It means even though in a loose bone, soft bone, we can obtain a high ISQ values. So only based upon the ISQ values, we cannot decide the loading protocols. It's very, very important things. So, soft bone, low ITV, high ISQ. We have to believe these two factors. So, it's good, it's the sign for the conventional loadings.
Can I ask, do you have cases, actually we have cases, actually medium bone,
Yeah.
hard initial torque value, but low ISQ.
Yeah.
What would you do?
I also had.
What would you recommend?
In single case, how about your insertion torque value?
50.
50. And posterior reason? Anterior. In this case,
Right.
immediate provisionalization, not immediate loadings. Out of
But the
occlusion.
ISQ is 65, it's not exceeding
70 or 75.
65.
Yeah. Yeah. But I always believe the bone density and ITV. Sometimes ISQ is the mechanical. It has some mechanical limitations. It means if you place in an anterior region heel ridge side, not complete heel ridges, but extraction and it only lasting as 3 or 4 months, there is no buccal bones. Buccal bone density is not good. So at that time, when you're checking the ISQ value is a little bit lower than we can expect the numbers. So in medium bone density and ITV was the 50 newtons, I believe these two factors. But when I'm connecting the provisional restoration, I always making the out of occlusions. So actually I believe that not ISQ, insertion torque value as
But
more.
what you're saying is that even if you have got a high insertion torque value and low ISQ,
Yeah.
you still would not do immediate loading.
It's depends upon the bone qualities. If I met the soft bone or medium bone, we can. Okay. Yes, it's very important. Well, when I talk about okay. In medium bone case, we can divide it into two situations. If this dark blue lines is more larger area occupied, we can think this is the little bit loose bones, soft bones. In that case, I follow the conventional loadings. But if I see, even though I see that this white blue areas, this is almost the same as little bit harder than soft bone areas. So I depend upon these dry colors. So professor say medium bone. Okay, I said this is the medium bone. I told this is the medium bone. So how about let's look this color code this very carefully. Apical area, it means middle half of the apical area is the hard bone density, right? How about the coronal position? There is you can see there's some red colors and deep blue colors in the buccal areas. That's why because I obtain a insertion torque value was over 50, but how about the ISQ value? Ringwall side is a 68. It means this bone density is a little bit poor, but this operation site condition is healing ridges. So after extraction, I waiting only 3 months, and then I place the implant. So when you're checking the ISQ values, crestal bone density is closely related to the ISQ values. It's a clinical appearance, not only clinical appearance, but also it's the simple logics, because the basic principle of the ISQ is the frequency of the crestal part. So if crestal bone is soft, in the case, frequency is very long wave. It means it shows some lower ISQ values. So using these kinds of the color system, I can estimate the ISQ value numbers, but how about this case? The previous case. This case, I placed the implant more deeper, right? So this implant placed the infracrestal of the bones, and when we connecting the smart pegs is relatively shorter than bone crest. It means it's a simple way. I'm tall. If somebody push me in this side, my moving degree is more higher than short, right? This is the basic logic of the ISQ value science. So, crestal bone hardness and implant vertical position is closely related to the ISQ values. That's why, because I cannot believe the ISQ value 100%. But the so normally I followed these protocols, especially around 70. I believe the two factors. It's very hard to say to English. Sorry for my English, but anyway, you can understand me. but the clinical meaning, clinical usage of the ISQ value is the time. It means like this. This is very hard case. So actually, some of the second molar is the contraindication for the guided surgery because mouth opening limitations. In this case, I cut off the buccal side of the stent, and anyway, using a stent, I was prepared the bone, and as you can see, the distal is the very soft bones. So 2.5 by 10 was the binary. 2.8 by 10 was the binary. And this was my mistake. 3.3 by 10 was the too large binary. And then I placed the 4.5 by 10. It was so difficult, so I tear out the stent and put in an implant. Checking the top value, it is under 10. ITV was the under 10. How about the ISQ value? 51. So it was too satisfying to me. Anyway, I placed the implant, one implant here. After that, how can we decide the loading period, loading times? Anyway, we have to wait, right, 2 or 3 months. After that, how we can checking the stabilities?
ISQ?
Yeah, right. So ISQ is very useful method in a time factors. So our suggestion is when you place the implant, you have to check in the two factors, ITV and ISQ. Right? If you have some brave heart, after 3 months, you can apply to the reverse torque, right? That's one of the scientific ways. But I have no that kinds of the brave heart. I cannot apply to the reverse torque. So the only way is non-invasive way is the ISQ. So let me show you one thing. After 3 months later, I checking the ISQ. I place the implant, and after 3 months later, I checking the ISQ. It shows the over 75. So I decided to connecting the provisional restoration. So 2 weeks later, I checking again. It is increased. It means this implant is also integrated. So ISQ is very useful method in the time factors. For example, after 1 year, how we can estimate this implant stabilities? Checking the ISQ again. If decrease, it is ailing or failing. So, but when you talk about the ISQ value, this is very important things. We cannot generalize the ISQ values. So we have to find some specific value in each implant systems. It's very important articles. So I don't know about the another system's ISQ value, but when you're using the enriched implants, 75 is very important numbers. But when you try to do one-day implant using the ArtGate, bone quality and insertion torque value is more reliable. Normally we obtain over 70s very easily, but bone quality and insertion torque value is also improved. So insertion torque value over 45 is more reliable because insertion torque value, in my opinion, insertion